Hi, in today's video we're going to understand functions that are of the form these are called cubic functions. They're part of the polynomials whereby the exponent is 3. These functions can be drawn in this form, or in most cases. The basic idea here is that when a function is drawn like this is a positive function. Or rather, when it's concave down, the value of a is positive. When it's concave up, the value of a is negative. Okay, keep that in mind. If you're given a function like and then you're asked to find the equation of this function, remember one thing, it's gonna be in this form. This is the most important element in this function. It's a cubic function. So one thing you can look for is these values. We call them roots. But since we're going to have 3 roots because of this, then our function will look like this. Assuming this is root 1, root 2, root 3. Our function is going to look like this. First, we're going to check our a here. It's concave down, so our a is going to be positive. And then you're going to say x minus root 1, x minus root 2, x minus root 3. And then we are done. I'm going to give you this example numerically. This is your Cartesian plane. This is minus 1, this is 2, this is 3, for argument's sake. And the question asks you to find the equation of this function. Like I said, we are going to say f of x is equal to a x minus root 1, x minus root 2, x minus root 3. This you do only if your function cuts the x-intercept 3 times, or the x-axis 3 times. 1, 2, 3. We'll visit other cases in which this function doesn't cut the x-intercept 3 times, or the x-axis 3 times. Okay, so we already know our a, and then it's positive, and we say x minus root 1 is minus 1, so it's going to be x plus 1, and x minus root 2 is 2, it's just going to be minus 2, and then x root 3 is going to be x minus 3, and then we have our f of x. Now we need to find the value of a. The value of a can be found by substituting the point in which our function will cut the y-intercept. So let's say we are told that the function will cut the y-intercept at y at this point. Let me call it point A, whereby A is this point, or rather A has these coordinates. A has 0 and 4. So on this point, when you're at this face, you need to find a, like the value of a, because you're not going to give out our function with a variable a in it. So we're gonna say x and y. We know that our y is gonna be 4, so our y is gonna be 4. A, and our x is gonna be 0. So you're gonna have 0 plus 1, 0 minus 2, 0 minus 3. And then you're gonna have 4. A, 0 plus 1 is just gonna be 1. And then you're gonna have minus 2, minus 3. And then you multiply this, you're gonna get 4 is equal to A. 3 times 2 is gonna be 6. So you're gonna have like 6A. And then A is gonna be equal to 4 over 6. Simplified form, we divide both sides by 2. 4 divided by 2 is gonna be 2. 6 divided by 2 is gonna be 3. So our A is gonna be 2 over 3. And then if we plug everything back to the original equation that we got, we will have f of x is equal to 2 over 3 into x minus, let's remember we're here, x plus 1, x plus 1, x minus 2, x minus 3, and then we are done. Okay, this is our equation. If you want to multiply it out, you can always do that using the FOIL method. So you're going to multiply this with this, this with this, and then this with this, this with this. After getting the answer here, you're going to do the same with the answer that you've gotten here. You're going to multiply out with this one. So I'm not going to do that in this section, but I've already done a video that helps you with that.